A small island nation, ringed with volcanoes and perched just below the Arctic Circle, has emerged as a world leader in renewable energy. By tapping into their bounty of fire and water, the people of Iceland have become nearly energy independent. Abundant rainfall and glacial runoff provide hydroelectric power, which represents 80% of the nation's electricity. This water also seeps into underground aquifers and runs head-on into magma-heated rock, which sits close to the surface in Iceland. This collision results in geysers, fumaroles, smoky vents, and the renewable source known as geothermal energy. Icelanders have used geothermal hot water for washing clothes and bathing for hundreds of years. But it wasn't until the mid-20th century that engineers began tapping the resource on a scale large enough to replace costly imported fossil fuels.
To us here in Iceland, it's native, it's indigenous source. It is much cheaper than other sources which we have, and it's environmental friendly. So I think there's a lot of benefits.
Geothermal water brings heating and hot water to 93% of the nation's homes. Geothermal steam generates 17% of Iceland's electricity. All told, geothermal provides over 50% of Iceland's total energy needs. The Nesjavellir power plant is a dual-use facility. It taps geothermal energy to provide electricity as well as hot water. Both end products begin here, in one of 15 boreholes drilled as far as 6,000 feet below the surface. The borehole's well is encased in cement to a depth of about 2,000 feet. Below that, the well is lined with perforated metal to let in steam and hot water, which rush toward the surface under great pressure.
A borehole discharges by itself. You don't need to pump it. Then you put a very powerful set of valves on the top to control it.
The mixture of steam and hot water is sent to the separation module. From here, the water and steam take separate paths. The steam heads for the demister to remove moisture that could damage the turbines. Excess water vapor is vented into the air, along with trace amounts of other greenhouse gases. Over a year, this power plant will release 12,000 tons of greenhouse gases, what a coal-fired plant releases in 5 days.
Geothermal power plant for electricity works exactly like you're using coal or oil in terms of turbine, except this is a natural steam. For electricity production, you're using actually the pressure of steam, not the heat itself.
The steam turns one of 4 turbines at a rate of 3,000 RPM. The turbines combine to generate 120 megawatts of electricity, which is sent on to Reykjavik. Nesjavellir is a high-temperature geothermal zone, meaning the water below the surface is hot enough to dissolve sulfur and other corrosive minerals. For this reason, it can't be used directly in the population's heating system. Instead, the power plant uses the geothermal water to heat cold fresh water pumped in from a nearby aquifer. In the first stage of heating the water, excess steam from the electricity-producing turbines is used to bring the cold water up to 125 degrees.
125 Fahrenheit is not hot enough for us, so we have to heat the water a little bit more, up to 86 degrees centigrade. It's about 187 Fahrenheit. And we do that in heat exchanger.
Inside the heat exchanger, the geothermal brine rapidly brings the fresh water to its 187-degree target temperature. The now scalding fresh water is pumped into the pipeline as it climbs uphill.
And from there, the water flows after the pipeline by gravity to Reykjavik. And the heat loss on the way is less than 2 degrees centigrade, it's 1.8. So you could say that the pipeline is, well, the insulation is almost perfect.
After providing hot water and space heating, this geothermal lifeline has enough heat left over to melt snow from the winter sidewalks as it passes under the streets. It also allows hundreds of greenhouses to grow fresh fruits and vegetables. Even the geothermal brine finds other uses. Unique in the world of power plants, the effluent from one Icelandic geothermal plant actually provides the warm, mineral-rich waters of the Blue Lagoon, a hugely popular spa. The Icelandic government has set an ambitious long-term goal: convert all the nation's cars, and even its fishing fleet, to run on clean-burning hydrogen, produced by geothermal and hydropower. If that day comes, all of Iceland's energy needs will be met with renewables. Iceland is far from the only place on Earth with rich geothermal resources. Generally, where there's volcanic activity, there's geothermal energy. One study estimates that 865 million people in volcanic regions from Japan to Idaho could get their electricity through geothermal. That's 17% of the world's population. But there's another form of geothermal energy, less exotic, yet very effective, that any homeowner can tap into. It's known as ground source geothermal. Nearly everywhere on Earth, about 8 feet below the surface, the air is a steady, cool temperature, between 50 and 75 degrees. To capture that air, a trench is dug below the building and tubing laid in. An antifreeze liquid, circulated by a small electric pump, passes through the tubes. In the summer, the liquid carries heat out of the building and mild temperatures in. In the winter, the warmer ground air heats the liquid, which flows into the colder building. It's in effect an underground heat exchanger. As the prices of heating oil and natural gas continue to go up, more people will start to look down. And like all renewable energy sources, geothermal will be there, waiting.